So one-sided limits, Unit 16, Worksheet 3. What questions do you have from that worksheet? Remember, we always try substitution first, and if that doesn't work, then we start trying our tricks with numbers that are a little bit more than or a little bit less than, the plus minus stuff, and then our algebra tricks as well. So, questions on any of those? Let's see, I think the first three were all like just substitution, like nothing crazy on the first three. And then things start getting a little interesting with the next set. Yes?
Can you do
number 10? Okay, as x goes to infinity. X goes to infinity. Alright, I'm going to do it sort of my preferred way first, and then I'll do it that shortcut way that I showed you as well. So the preferred way is, my preferred way, maybe not your preferred way, is when x gets really, really big, then the one thing, or the term that matters most, is the term that has the highest degree. So that would be negative 4x cubed in the top, and 7x to the fourth in the bottom. So as x goes to infinity, what matters most for this particular one is negative 4x cubed over 7x to the fourth. But then the x's can reduce. So that's negative 4 over 7x. And as x gets really, really, really big, negative 4 divided by a really big number. What's negative 4 divided by a really, really big number? 0. So my answer is 0. Do you remember the shortcut catchphrase? If not, that's fine, because I'd rather you do it this way anyway. Top no, bottom O, equal co. And this was this is like which one's bigger, the top, the bottom, or the equal? Well, bigger on the bottom, so this was a bottom O case. And since there's 3 infinity problems, 3 infinity limits, and 3 cases, I bet there's one of each without actually doing them. It's not hard to see. 11 is equal co, and 12 is top no. What about the middle section? That's where you have to do that tricky thing, so 4 through 9, where you have to plug in something a little bit bigger than 2, and you end up with something a little bit bigger than 0, or a little less than 0, and you end up having to figure out positive or negative infinity. You need to do one of those? Number 4. Alright, so first pass is just plug in 2 and see what happens. 2 minus 5 is negative 3. 2 minus 2 is 0. Okay, so that's not going to work. Divided by something close to 0 is headed to infinity, but I need to know like big infinity or little infinity, like positive infinity or negative infinity. So I'll plug in something a little bit bigger than 2, because 2 plus. So 2 minus 5 is still negative 3. A little bit more than 2, and this is another way that you can write this. You know, normally we substitute whatever is written there, we plug that in. Well, you can still do that. 2 plus means 2 plus a little bit, 2 from the right. So what's 2 plus a little bit minus 2? Right, 0, but a little bit bigger than 0. And so some people will even put 0 plus, a little bit bigger than 0. If you want to put 2.001 and then 0.001, that's fine. You're still headed toward negative infinity. I'm pretty sure that's right.
Well, it says negative infinity but does not exist.
Oh, right, because anything that's an infinite limit does not exist. It's a special case, or it's one of the cases of does not exist.
So then when was the one where the answer was infinity?
If the answer is infinity, the limit doesn't exist. Now, sometimes I get lazy and don't write D and E like I did on that one. But if the answer is infinity, that means the limit doesn't exist. The limit only exists if you get a number for an answer. Infinity is not a number.
So do we always need to write both?
So I want you to write both. Yeah, I need to look at the test. If it's multiple choice, it's not going to be one answer is infinity and one answer is D and E. Like it won't be that. All right, so we've done kind of one of each. Do we need to do anything else on this one?